Hello, everyone, and welcome to another episode of the Real Estate Development Insights podcast, where we bring you ideas, experiences, and insights about the real estate development industry. My name is Payam Nursalihi, and I'm your host here. Our guest for this episode is Simon Edwards. He's an acoustical engineer at a company called HGC, and they specialize in acoustic noise and vibration for buildings, new developments or existing buildings. In this episode, we dive deep into the topic of acoustics. As you might have heard, acoustical complaints are one of the more common complaints that a newly built building experiences, and the developers have to deal with it. Basically, what ends up happening is that people end up hearing a little bit more from their neighbors than they like to. And in this episode, we dive into how to deal with that, how to look at that in the design stages, how to prevent that, hopefully, from happening or mitigate the risk of it happening. And some of the ideas and solutions that we discuss are actually pretty easy and relatively cheap to implement. Simon is one of the people who had the opportunity to work on a few mass timber projects early on in the game. And he basically used this opportunity and his previous experience in field testing and gathering data in acoustics to create new systems and new way of thinking about the acoustic in the mass timber building. And that's why we do end up spending quite a bit of time in this episode talking about mass timber construction and the acoustical concerns that surround any type of construction for that matter. But that being said, Simon does work in different types of buildings, not only mass timber. We do talk about the role of an acoustical engineer in the overall development process. We talk about some challenges and some code shortcomings that we're dealing with right now, and hopefully some trends and technologies for future that can help all of us make better buildings and buildings with fewer acoustical issues. If you'd like to find out more about this episode or the topic, please go to our website at realestatedevelopmentinsights.com, realestatedevelopmentinsights.com. That's all one phrase. And I hope you enjoyed listening to the show. And as always, please remember to subscribe. Thank you. Hi, Simon. How are you doing?
Hi, Payam. I'm good. How are you?
Pretty good, pretty good. Thank you very much for being here. And why don't we start by giving some introductions? Maybe tell us a little bit about yourself, your background, where you're coming from.
Sure thing. So my name is Simon Edwards. I'm an acoustical engineer. I've been working in acoustics for a little over 8 years. I work for a company called HGC Engineering, which is based out of Mississauga. And so a little bit about me and background. I used to play music full time. My academic background is in mechanical engineering. I studied mechanical. While I was studying, I was in a band, and we got a fair amount of success pretty early in our careers. And so we leveraged that success into a full-time music career. I was with the band for about 10 years, during which I also did a master's degree at U of T. And then somewhere towards the end of the band, I decided that I wanted to, passionate about engineering, and I wanted to kick off that engineering career. I actually had no idea that acoustical engineering existed. I think a lot of people don't. There aren't many programs at university that specialize in acoustical engineering. So I had one acoustics course, but I kind of thought that was it. I was applying for mechanical engineering jobs, and then I saw this acoustical engineering job posting, and I thought, wow, that looks cool. I'll apply, but I'll never get it because I didn't study acoustical engineering. Sure enough, I later found out that not many people do. A lot of people who work in acoustics from mechanical, but we also have people that come from civil, environmental engineering, different engineering paths that have sort of developed this acoustical foundation. And
so you went from making a lot of noise for about 10 years in the band to trying to figure out how to not make too much noise, or at least not to transmit too much noise in the building, right?
That's right. It's funny. A lot of people who at HGC are musicians, even though, is not an inherent part of my day to day. I think, there are certain aspects, things like, understanding reverberation and appreciating differences in frequencies, that comes from maybe having a certain musician's ear. But other than that, I'd love to, I wish there was more music. People, when we bring speakers on site to do testing, often we're playing things like pink noise, and contractors will crack jokes and say, which album are you putting on for this test and whatever. So, they're not as related as some people. They're a little related for sure, but it is definitely a path that, I'm passionate about for sure. It's definitely a different, unique experience for me, especially, and this really ties to music and acoustics. I mean, my mom is deaf. My dad is
Right.
has always kind of been a bit hard of hearing as well. And so I really grew up with very little music in the house at all, very little, like almost no instruments until, maybe I was a teenager, and just, no appreciation for acoustics, for sound transmission in the house or hearing, and feeling different vibrations. And so once I got into acoustics, I could start to play around with my mom, who I suppose, I mean, she is deaf. I think she has maybe a couple % of hearing in one of her ears, and that allows her to maybe pick out a doorbell once in a while. And so I was able to kind of put headphones in her ear and play around with different frequencies and see how she perceives sound. That's really once I got into acoustics, when I started to really appreciate, even for the hearing impaired, how the importance of recognizing frequency content and things like that on a day-to-day.
As much as you think that you fell from mechanical engineering to acoustic by chance, it doesn't look like that. It almost seems that there was a trend in the background that was running, but
Yeah,
we'll explore that in a different episode.
Yeah, fair enough. I'm grateful that I found the industry for sure. It's been a good industry to me.
And I think the industry's sharing some of that sentiment with you. So with that segue, I'm gonna go to a little bit more of a industry topic. So I want to go back to how originally you and I connected. I think it was about a year or so ago. Then it was probably right after the whole change in the mass timber regulation that happened. And I was doing some research and trying to figure out who's working in this business, who knows what they're doing and what knowledge is out there. And I came across your name, and so that's how basically I tracked you down. And I'm like, okay, seems like there are a lot of questions about acoustic and mass timber, which I want to really dive into in the next few minutes. And so I came across your name, and you guys have done a few things there. But before we dive into mass timber, and hopefully we do that in detail, why don't we just set up some definitions and some broad expectations of what is it that an acoustic engineer do? What does someone who is not necessarily in the industry need to know about what you do to be able to use your expertise? And I'll also put this into context that it's a proverbial or anecdote out there that says that probably number one claim that residents have from the building is acoustic claims, and especially in the world that
complaints,
the world, and so let's start with that.
Sure. So, what does an acoustical engineer do? Well, there's a few different kinds of acoustical engineers. I mean, at HCC, we have a team of acoustics that focus on industrial acoustics and others that focus on environmental acoustics. That has a lot to do with planning studies, noise and vibration feasibility, addressing rail and building foundation isolation, things like that. And then I specialize in building acoustics. And so really that has to do with sound transmission, often, in the residential context, sound transmission between suites and other areas. That could be suites, that could be amenities, mechanical, electrical rooms. Also vibration isolation of mechanical, electrical equipment, things like sound impacts from M&E equipment as well. So if you have, a chiller, how does the chiller noise or fan noise through a duct, things like that. So those are some different ways, that we get involved in the building, things like gym floors, other really like architectural and M&E recommendations. And then that comes into a bit of a specialty items as well. Things like garbage chutes, elevator vibration and noise is a really big one, especially, when I think about buildings where we get calls after they're built instead of before. Often we get a lot of calls about things like elevator noise and gym floor noise and things like that. I'm skipping ahead a little bit, but so in terms of what an acoustical engineer does, that's a little bit about, what we do, what we bring to the table. I think, what is really important for a developer, what would I like developers to know? I think that, as you said, noise is such a common complaint in buildings. we get involved in a lot of legal scenarios where unfortunately lawyers have already gotten involved and things like that, and that can cost a lot of money for a lot of people. And so I think that our goal coming in to the design of a building is to be involved as early as possible to provide feedback on addressing acoustics in as cheap a manner as possible. I mean, before we built the building, even before we've gone
You
too
still
far in
can do
design.
something about it.
Absolutely. I mean, to address these things on a practical, a clear and practical level early is so important, because later on it just becomes such a huge headache. And the other thing is that the reality is that what people actually, budget for an acoustical engineer on a job and getting that design feedback is really very little in the context of the actual design, what the rest of the design team, especially the primary consultants. And not only that, but also the costs associated with not doing something, with doing too much. I've gotten involved on a lot of projects where architects are being relied on for acoustics, and architects are very good at architecting, but when it comes to acoustics, fair enough, their knowledge and experience level is only going to be so limited. And in some cases, what that leads to is actually over designing certain things. I got involved in a project a couple weeks ago, and the first thing they sent me, they said, we're very, very tight on budget. We have some questions. And the first thing they sent me, I said, well, let's value engineer a ton out of your, floor ceiling assembly. I'm not sure how much money I sent them, but I know I for sure saved them more than they're paying me over the life of this design. So, I think that some people, that is certainly something I think developers should keep in mind when they're exploring, is acoustic something important to budget for, to keep in mind, during the design, is how much of a net positive impact that can have, not only during design, during construction, and of course after occupancy as well.
Right. And that's, to be honest with you, that's one of the reasons I wanted to have this episode definitely with you, is that I've been seeing it throughout the years that I've been working in the industry, that, like you mentioned, not too many people, first of all, know that there is such a thing in this acoustic engineer. That has been changing over the past 5 to 10 years, say. It's been becoming more common, but still, I agree with you 100% that it is looked at like a secondary subset of consultants, if you may.
Right.
Which it might be in terms of the overall scope of work, which is
certainly
fair.
We're certainly involved
fair.
on a less involved basis as architect, M&E, structural engineers, and that's
Correct.
fine, because that really allows us to work on more projects.
Right.
An architect, I can imagine, only works on a couple projects at a time. So we get involved when it makes sense. We'll provide a design review typically, go through that with the design team, make sure that's incorporated into the drawings, and then at that point, we can sort of sit back from that, knowing that the design has incorporated the appropriate acoustical features. And then, the next stage we get involved would be, shop drawings and site inspections. So there's certainly a gap of time there where the primary consultants are continuously involved and meeting, every week and continuing to show kind of little last minute details, whereas our scope is a lot more limited in that effect.
And that's very true, because one thing you mentioned that I want to emphasize is that there's a right time for people like yourself, and there are other disciplines that share the same situation as an acoustic consultant. There's a prime time, there's a right time for them to be involved in the project where you actually can still make the changes very cost effectively. You don't have to go back, and like you mentioned, I know of projects that they've had to go back and fix an acoustic issue at hundreds of thousands of dollars cost, and rip whole things open and try to fix it. And no one wants to be part of that nightmare situation. But no. So that being said, let's dive into mass timber, which is it fair to say that's your main specialty, or how would you talk about it? I know I'll put context that you are one of the people who is, at least in the industry in GTA in Toronto, that I know of, which is further ahead of everyone else in terms of the data and testing that you've done and the work you've done. But is it fair to say that's your specialty?
Yeah, I wouldn't say that's the majority of my time. I hope that it will become that. The truth is, we started the first mass timber building in Canada, I believe, was built in 2019 on Queen Street in Toronto. And so that's how we got started. Nobody really knew much about mass timber before that. And then since then, it has certainly ballooned out. I have upwards of at least 10 mass timber projects on the go right now, and a few that recently have been completed, and then even some more that are coming up. And so it's a really exciting time for the industry, but the reality is that we're still working our way up until maybe you have acoustical consultants dedicated only to mass timber. I don't think we're quite there yet, but we developed, we understood the importance of developing a database of testing, which just didn't exist at that point. And so being able to learn more, to get out into the field and take measurements that hadn't been taken before, gave us a new level of understanding of how can we get exposed CLT ceilings, whereas a lab will tell you that CLT panels have a lot of sound transmission going through ceiling to ceiling. But yeah, continuing to expand that experience and data to support different people, I think mass timber has certainly become a very exciting part of my portfolio, and I'm excited to see it continue to grow.
That's one of the questions that I get asked, I guess, quite often is, what is mass timber? Like, should we, especially when you talk about mid-rise projects, something that's like 4, 5, 6, maybe up to 10 stories, should we start switching them to mass timber? Whereas for the past 5 or 6 years, most of these projects have been, I want to say, primarily on the smaller side, they've been hybrid structures, and on the taller sides, they've been concrete, which has been the king there for a while. And so I guess let's start with this question, that if I'm a developer, if I'm thinking about doing a mid-rise project, let's say a 5, 6-story, 8-story building, and I want to go to mass timber, how worried should I be about complaints, noise, and acoustics 5 year, 10 year down the road, or 2 years down the road, considering that not too many residential buildings are currently built and are being used with that purpose?
So the truth is that every type of building structure, including poured concrete, including wood frame, have acoustical deficiencies. In poured concrete, usually you get pretty good STC, which is airborne noise transmission that refers to things like voices, music. But, poured concrete, it can notoriously have quite poor, impact transmission, so a lot of footsteps. That's a very common complaint. The other thing about something like poured concrete is that, the entire structure is highly coupled. So once something like elevator machine vibration gets into the poured concrete, or weight draw vibration gets into the poured concrete, it can travel 3 or 4 floors away. You can get complaints from a whole assortment of suites. And so different types of structures have different advantages and disadvantages. Timber is no different in that sense. There are certainly areas of mass timber that require more consideration early in design. So it's important to take a look at things like, direct sound transmission, choosing your assemblies to, address sound and airborne sound and impact sound coming straight through, but also looking at indirect sound transmission. And that's also called flanking sound transmission. That's something that's really important in mass timber. A lot of people, and this is especially the case when developers are relying on architects to provide that acoustics knowledge. A lot of people think only of direct sound transmission. They think, I have a suite beside a suite or above a suite, my wall, what's my floor ceiling assembly? Is that, what are the ratings? What are the SDC and IIC ratings for airborne and impact sound? Is that, are we meeting our targets, and is that it? That is a great place to start, but the next step after that is, okay, well, what are my indirect sound transmission paths? What's going through the ceiling, through the floor, through the exterior wall, through the corridor wall? I mean, there's a ton of different indirect paths that can certainly result in, when you're in the field, when you have somebody standing on one side and standing on the other side, you can hear conversations, you can hear a lot of sound because somebody hasn't thought of that indirect sound. So really when thinking of mass timber, specifically, I think that, taking a look at those indirect sound transmission paths, making sure that you're addressing the sound going through the ceiling, making sure that you have something, usually a lot of mass timber buildings include some type of topping. So making sure that topping, whether it's dry or wet topping, is interrupted at demising walls. That's important for limiting sound going through the floor. So, these types of considerations for indirect transmission is really important with any lightweight structure, including wood frame, but this is also the case in mass timber. But some of the benefits of mass timber acoustically, in some sense, the modular ability of it. So coming back to that elevator vibration example with poured concrete, you have the opportunity to isolate mass timber panels from each other, which is something you can't do in a poured concrete building. And so
That's
that
true.
really provides you that extra stage of isolation, whether it's pipe isolation or conduit isolation, equipment isolation, flexibility of designing the mass timber building with isolated that the vibration or reduce the amount of vibration traveling through those joints and through the structure. That's something that you can't get out of a poured concrete building. So certainly there are advantages and disadvantages, but those are just some of the kind of early things to wrap your head around when exploring mass timber from an acoustics perspective.
So what I gather from what you just said is that yes, there are a lot of things to think about, but while you're thinking about it, don't despair, because there are some upsides that you can probably only gain from something like mass timber. And I guess let me take that as a segue. And I know in one of our conversations that we had earlier on a few months back, we went through this whole effect of the actual concrete itself, that I think originally it was introduced to help mass timber with fire rating, at least as one of the initial thoughts. But my understanding is that that actually ended up working both ways and help a lot with acoustics. And maybe walk us through that. And I want to use that as a segue to go into I can't remember the name of the project, unfortunately, but the one in Kitchener. And
Yeah,
maybe YW,
absolutely.
yes. Maybe walk us through that. And yeah, I have a couple of follow-up questions coming up there.
Sure thing. So, concrete so certainly helped guide the early days of mass timber with respect to both fire and acoustics. And I think there's a lot of things, I'm familiar with a few fire engineers who work on a lot of mass timber with me. And, we often kind of make jokes about how we're fighting the same battle to get the same things installed. But so an isolated concrete topping, it provides a huge benefit in any lightweight structure. That includes wood frame, that includes something like a steel deck. You can get a lot of low frequency booming impact noise. So think about somebody walking around in socks upstairs. It's more of a thumping. That is very, very hard to address without any sort of mass above your floor ceiling. And mass timber on its own is really not that heavy in the context of things. And so at addition of an isolated concrete topping above, in addition to adding your fire rating, gives you that extra sound insulation that you need from an airborne perspective as well for voices and music, but also from that footstep and thumping perspective to improve really both approaches. And so that concrete topping has been really important. I mean, we see that on almost all mass timber projects, not all. There has certainly been a shift in the industry, and I think it's a really interesting shift that it's certainly not discouraging. I am encouraging it where it makes sense to dry topping. So this is where we try to avoid concrete completely. I mean, of course, there are sustainability components to that, but from purely an acoustic sense, the dry topping make for a little bit more of a simple installation. You don't have to worry about concrete being over poured and seeping around and potentially short circuiting.
Can you walk me through or walk us through what is a dry
Absolutely.
topping? Like how do you define
so a
it?
dry so whereas a concrete topping might look like something like 1.5 or 2 inches of gypcrete or concrete above, usually about a 1/2 inch of rubber isolation material below. That would be a typical concrete topping. Whereas in a dry topping, you replace that concrete with something like 2 layers of plywood or cement board or some type of proprietary material. So these are things that don't involve any pouring of a cementitious topping. And so those dry toppings also have a pretty interesting acoustical performance. And they are, I was just talking to somebody today at lunch about how, they're developing, new research, new R&D, new technology coming out to reach higher performances, with still relatively thin dry toppings, not having to build it up too much above the CLT, but being able to avoid concrete altogether, still get your fire rating with the dry topping, with the with the proprietary type of plywood, while also getting your acoustic performance. So from a purely direct standpoint of, a room above a room and direct STC, direct IIC, the conversation of a wet topping, such as concrete or gypcrete, versus a dry topping, such as plywood or cement board or something proprietary. That's been a really interesting conversation so far, and it's great to see more acoustic suppliers, I'll say, coming out with different data for their dry topping, isolation materials, and to see how that can continue to promote sustainability in the industry and promote modular construction and decrease construction times potentially, and so that's been an interesting trend. Now, one thing that is important, and I might be getting a bit of ahead of myself again, and that is still very relevant in the wet versus dry topping conversation, is that when it comes to wet toppings, something about mass timber that has been, probably to me my favorite development, I will say, over the last few years, is that a lot of lab data for continuous CLT panels over a suite demising wall. So this is where you have one CLT panel that, for example, can span 2 suites as the ceiling over 2 suites. A lot of data in the lab suggested that you will get a huge amount of airborne flanking through that panel. And so if you're doing an STC test, an ASTC test, you put a speaker on one side, you measure on both sides, you're going to measure an ASTC result that does, in the low 40s, something that doesn't meet the National Building Code, the Ontario Building Code, the International Building Code, not compliant in a lot of areas. That was really the big fear. I mean, that's how, I think that's partly how mass timber got its rep as, a scary acoustics endeavor. And so when we started conducting some of this lateral flanking testing with an isolated topping above, we started getting in multiple buildings this phenomenon of damping from this isolated topping above on this continuous CLT panel, that we are able to boost that up around, ASTC 50, a very notable increase from what they're getting in the lab. And
sorry, is that without the topping, you said, or
that's
with
an isolated concrete topping above? And so the question comes down to, the effects of the specific differences. We actually have some testing coming up, which will be really great, where we're doing the same test in 3 very, very comparable situations on 3 different floors of a building, where we're doing a flanking sound transmission test with no topping above whatsoever, one with a wet concrete topping and one with the dry topping above. And that will give us more information on dry toppings, and if dry topping can provide that same benefit where you have continuous CLT panels. So that's a little bit of a hole right now when it comes to dry toppings. Can we use continuous CLT panels with dry toppings and not have to worry, with exposed ceilings, of course, and not have to worry about ceiling to ceiling flanking? So yeah, we hope to answer that question pretty shortly in a matter of a couple months. But in the meantime, the isolated concrete toppings have really proved to be a huge improvement to lateral sound transmission, and that's been a very significant benefit to the mass timber industry as more and more people strive to build these buildings with, these beautiful exposed ceilings.
And to just put things into a little bit more perspective, from the reason that continuous CLT is important and is worth looking at is because from an efficiency of construction perspective, you could span over 2 units with one length of CLT. I know some companies locally, they are capable of producing CLT panels that are long, like 50 feet in length, right? But we are breaking them up just because of what you just mentioned, because of the fear of potentially the noise transmission from one unit to the other. And there are also, I think there might be some code implications right now that won't really allow us, but that's definitely a worthwhile exercise. I'm really interested to know what that result come back with, because hypothetically, if I can drop one piece of CLT and cover 2 full bays, and two span over 2 units, that's going to cut my crane time in half.
We're starting to see that on a few projects. I mean, we're seeing that on a few projects already where they're spanning a couple suites at a time. And so that's been great to see. Now, you get into a bit of an interesting situation on the top floor. Some of our projects are pouring concrete toppings on the roof because otherwise we can't guarantee that you're going to meet, because the lab suggests that without a concrete topping above, you're not going to be able to meet code in that lateral sense. And so we have some projects that are adding the concrete topping. We have other projects that are changing the CLT panel layout only for the roof, so that on the roof you have CLT panels spanning only 1 suite, whereas on all the other floors you're going to a couple suites. And so there's a couple different approaches there on how we can address that. But Yeah, no, it's been an interesting, a journey, I would say, over the last
Right.
few years with this, but it's been great. It's been great to work with architects, developers, project managers such as yourself who are passionate about mass timber and who are passionate about leaving ceilings exposed in an industry where for a few years the rep the stigma, I'll say, in the industry is that, oh, acoustics is going to be terrible unless you put a drywall ceiling in. And even the mass timber suppliers, are so excited by the data that we have to support leaving ceilings exposed that's part of the reason why we get some of these referrals is people saying, if you want your ceilings exposed, you got to give these guys a call and they can support that.
It is a big deal. Like when you think about it in the broader context of the cost of the project, obviously not having to do drywall ceilings in both cost and time on site, there's a saving.
Absolutely.
There is certain aesthetic appeal also where you
Sure.
have all the wood and you get the warmth of the wood. That's I
Absolutely.
think that has always been one of the main selling points when it comes to using mass timber. So I want to go back to the Kitchener project, and I remember that you were at some point thinking, and I think it's worth exploring a little bit more, that you might have to use a checkerboard pattern.
That's right.
Was that on the floor or was that on the wall?
That
First
was
of all,
for so the mass so YW had mass timber everything. It had mass timber exterior walls, suite demising walls, and floor ceiling. Excuse me. And so the suite demising walls had to be covered. They were only 3-ply, and really, even from a direct sense, they had to have some type of insulated partition on both sides, or else we weren't going to get the direct performance. So that sort of covered the risk of flanking from that perspective. But then we had these continuous CLT panels. We did not yet have the data. In fact, YW was one of the first projects where we developed some of this data because we did some testing before they built the ceilings. But in the meantime, in design, the theory was, the lab data was that you could not have continuous CLT panels with no ceilings. And so what we did was we did a checkerboard ceiling pattern where every pair of suites that are connected by a continuous CLT panel have a ceiling in one of the two suites in order to address that ceiling to ceiling planking path. And then on the flip side, we also had these CLT exterior walls that again were these continuous panels that go up and down the building. And again, the same concern of flanking through this exterior wall panel. And so we, had to address that by leaving some of it exposed and again doing some type of checkerboard that, we tried to expose the exterior wall in suites that didn't have exposed ceilings. And so it was a bit of a exercise and a learning opportunity. And Matt Bullen, who was the architect on that project, he and I, we give presentations together sometimes and we chat a lot. Architect, very big supporter of mass timber, and he likes to joke about the level of professional conflict, especially now that we've grown a great personal and professional relationship. But he jokes about sort of the professional conflict that during YW, I was the bad guy. Everybody wanted the exposed mass timber, and I was the bad guy who came in and said, look, the data is showing that we can't do this. We, in order to meet code, this is what we're going to have to do. And so I accept that. I accept the,
But so was it you who were pushing for actually leaving it open as a checkerboard, or was it Matt?
Well, no, I mean, Matt wanted no ceilings at all,
Oh,
so
at
the
all. Oh,
checkerboard,
everything gone. Gotcha.
yeah, so the checkerboard was sort of me that said, the data suggests that leaving everything open is not going to meet code. And what's interesting is that finally we were able to get out and testing. They had built almost all the ceilings except for a couple, and we tested in the suites without the ceilings, and we got really good results. And so the next building I did, with Matt, we did it differently. We did it without the ceilings. And so, certainly, or even in block 2, right? Block 2, YW had a second phase. And so we were able to, explore things differently in future projects. And of course, get into more projects to test the same thing. It was hard to rely just on one, one or two tests in one building. We want to make sure that we're really establishing a baseline of experience. But beyond that, we've definitely been able to impart that on a bunch of different buildings to avoid that checkerboard pattern. But certainly that, that pattern started with me and with me pushing for for the acoustic standpoint and the lack of understanding that the North American mass timber industry had at the time. And I'm glad that I can contribute this knowledge to the rest of the industry, the rest of acoustics, and developers to sort of open up some opportunities. Now, I will say, now the industry kind of stays ahead of me, right? So we started doing this testing with 5-ply, and we go, oh, great. Like, I think we have this data to support leaving 5-ply exposed, no need for drywall ceilings. This is great. And next thing I know, I'm getting calls about 3-ply floor ceilings. And I'm going, well, hold on a second. Like, we haven't developed that database yet. So I think,
That's one of the beauties of our industry is that we keep pushing. If you can
that's
do it
right,
for 5,
absolutely,
why not for
100%.
3, right?
And so, that's more data that we're looking forward to getting this summer, or even, the effective green roof. I mean, does the weight of the green roof give you the same damping as the isolated
Right.
concrete topping? I have no idea, but we're going to find out in the next couple months of testing. So,
You know what? That's actually a very good point.
as the industry progresses and we gain more data, and then the industry changes and goes 3-ply, and so it's been a lot of fun and very interesting. I continue it sometimes to be the villain, I think, unfortunately, but of course it's all in good intentions. I want to
As
protect the
engineers, I
clients.
think we have that role sometimes. We have to have that role from time to time to say
Right.
the
Yeah.
unpopular ideas that not everyone wants to hear. But
Yes.
you touched on a couple of things that I don't mind expanding on if you're okay. One of them is this whole mass timber, and like we're diving into this mass timber quite a bit, but mass timber has been around for quite some time. It's not new. It's true that in Canada a couple of years ago, or a few years ago, the code started allowing more use of mass timber, but it has been around. Europe has been using it extensively for
Right.
decades in many more applications than we have. I guess, is there an area of concern, or I should say, area of improvement that you might think of and say, you know what, it would be really good if our code in next iteration or our industry or our design community would think of this way or that way to basically pick up some good practices or best practices from what people are doing in Europe or other places for that matter. Does anything come to mind?
Sure. So I mean, Europe it's a bit difficult sometimes to compare, especially even the test data, because not all mass timber is created equal. And so, we, here we see a lot of 5-ply that's 7 inches, 175 mils, versus Europe, where a lot of it, I see 5-ply that's 95 mils, or, in
Right.
BC where it's 105 mils. So you get different depths of 5-ply, and of course all of those have different acoustical performances and different acoustical characteristics. So from that respect, there's we can only sort of draw so much comparison once we start changing the CLT too much. But in general, the guidelines and the even sort of municipal requirements are certainly much more stringent in Europe. One area in North America, Canada actually specifically, because the US is a lot better, but one area in Canada, the codes are really quite relaxed, is with footstep noise, with impact noise. So that's IIC
Right.
ratings.
IIC, yeah.
And that applies not only to mass timber, of course, that applies to really every residential building. Like I was referring to earlier, it sort of has there's two types of impact noise. There is the low frequency thumping that I was alluding to earlier, where you kind of think about somebody walking heavily in socks. But then you have like the high frequency tickety tacks of, somebody walking around in high heels on ceramic tile. And those two things are completely different. So when you just see something that has a low IIC rating, it doesn't tell you if it's really bad at high frequencies and the tickety tacks, or the really bad at the low frequencies and the thumping. And by the way, the tickety tacks, that's of course a very technical term. And so from IIC, they've developed a new standard only in the last few years called HIIC, so high frequency IIC, and they're in development a low frequency standard called LIIC. I can tell you that the folks at ASTM are quite opinionated during those meetings. So I guess, acoustical engineers are very passionate about making sure the standards are right. And so, that's been developed. So as IIC shifts a little bit into LIIC and HIIC, I think it becomes a lot easier to argue certain requirements in the code, and because then you don't have to worry about something meeting IIC, but still having way too high thumping sound, to get those requirements right. But that is a big thing that I think would benefit the industry. Right now, the reality that IIC is not a code requirement, it's only a code recommendation, that we get tons of calls from people who, are property managers in existing condos, and somebody's complaining about footstep noise from the people living above, or furniture moving, or, things dropping on the floor, especially when they have kids. And the reality is that there's not sometimes there's IIC ratings in condo documents. I do recommend that. That means that if somebody's going to rip out their carpet, they can't just install any floor they want. They have to think about the underlayment. But other than that, that is a very common call that we get. Another thing that's not really a code requirement, and that that leaves it in a gray area, are really noise from building services. So when you think of things like elevator noise in a suite, right now, my life would be a lot easier if there was some big black and white, 35 dBA limit, and we showed up and said, yep, this is 36. That's too loud. Have a nice day. But the reality is that that's not the case. And so what a lot of acoustical engineers draw on when they are outlining their targets, when they're addressing and evaluating whether or not a sound is too loud or not, things like garbage chute drops, weight drops, an engineer is looking at a lot of different resources that come into it. So that could be codes in other areas. That could be things like ASHRAE or ANSI criteria for different things. So pulling together guidelines and resources, that's how we develop our criteria. And that's what we would, when we go to court, that's how we would have to establish that criteria. But those are certainly some things that are missing from a potential, not from potential, but from the Canadian Building Code, and hopefully would be added in a potential, code amendment to
revision or something.
Yeah. Revision, that's right. Thank you, to firm up those things. And I think that would hold the industry, a little bit, it would hold the industry to a higher standard and reduce, complaints from those things to more of kind of a hand-wavy approach to design.
And you hit it on the head. Like, I think, especially when we get more innovative systems like the mass timber, I'm pretty sure like what we're seeing in the mass timber, hopefully, I shouldn't say I'm sure, I'm hopeful that this is just the beginning of a new spectrum of products that are going to come out.
Mm-hmm.
Hopefully more sustainable way of building buildings. And you make a great point that without clear-cut criteria that says, yes, this is good, and yes, maybe this one is gray and the other one no, it leaves room for too much judgment, which frankly, looking at it from a developer's perspective or a builder's perspective, we're in the business of risk management. We're in the business
Absolutely.
of having bright minds like yourself trying to tell us what's right and what's not, so we don't take on more risk than we
of course
absolutely should, right? And yeah, so that would be a welcome change, and hopefully we see it sooner than later. I guess
it's tough because it does, a lot of these types of things depend on the area, background sound in the area, how often it happens. So, one thing that we get, I do a lot of actually, fitness, like weight drop investigations and fitness investigations with gym floors. And that's a very common source of complaint in existing buildings where somebody will call us. And of course, weight drop, noise can travel a few floors up. So the unfortunate thing is that a lot of developers and ID professionals, people who design gyms, have sort of been duped by the industry a little bit to think that, any rubber floor is good enough to address weight drop noise. And it's unfortunate because it's pretty far from the truth. I mean, the reality is that a thin 10 mil rubber tile, is great at reducing noise in the gym. You drop the weight in the gym and it doesn't really sound that loud, but it can travel 4 or 5 floors up and start shaking somebody's picture frames. And so,
interesting. How do you deal with that? Actually, that's a good thing.
In a concrete building, which is especially where it travels the farthest, that's where you have to get into it, looking at the gym floor itself. And so looking at retrofitting that gym floor, you often get into much thicker gym floors, which becomes very complicated when the building is done. If it's a poured concrete building and, or the building is poured, you could have added a slab depression in advance, but now it's too late. And so adding transition pieces and accessibility ramps and all of those things that can get a bit complicated. And so when it does come to assessing weight drop noise, we recently were involved in a pretty contentious court case, and we were going up against somebody else, and the lawyer, was saying you really need to outline your methodology, to the judge in such a clear way. And it really kind of forced us to get even more resources. When we were drawing upon a few things, and we were like, okay, well, we need like 10 resources. We need more resources to draw upon this. And when you're evaluating weight drops, because it's not as easy to say weight drops shouldn't be more than 30 dB or whatever limit you want to say, because the question is, well, how often does the weight drop happen? What kind of gym is this? Is this an F45 where you have classes every single morning and throughout the day? Or is this a condo gym? Or is this a gym in a senior's residence where nobody's ever going to lift a weight more than 10 pounds? And so this becomes, not a simple exercise of asking yourself, is it above or below 30 dB? I mean, you can't just set that target, because it does come down to what kind of gym is it? How often is the weight drop? What is as you said, it's risk management. What is the risk of complaining? And what we have to say in these situations is that what we're doing is we're trying to evaluate typical gym activities. And typical gym activities is in and itself very difficult to define accurately.
It's hard to answer that
setting.
question.
And so, if somebody comes, even if you install an amazing gym floor, even if you put in like a 3/4 inch, very soft gym floor that, that you can walk on properly, but will, absorb a lot of that vibration. And somebody comes in and starts throwing kettlebells from above their head, dead ball slams or whatever, you're going to hear it pretty far. Like there's no gym floor that you're going to install that's going to address that. And so, you have to kind of explain not only to a judge, but even just to the developer, to the design team, that what we're doing is we're doing risk management. We're trying to address the risk of complaints by essentially saying gym activities will be inaudible or quiet or marginally audible, whatever our target is, will be acceptable in the nearest suites, nearest receptors. But if somebody comes in and goes crazy, it's going to be too loud. And so the idea is A, people shouldn't be allowed to do that. And B, if they do that anyways, it should be rare enough that nobody's really going to complain. And that is the reality. I mean, the reality is that when you do have a good gym floor in, the odd time that, people hear lots of noises in multifamily buildings. I mean, they hear a
that's part of it. That's
by.
Part of the whole package of living there, right?
You hear a truck drive by, you hear people walking in the corridor. And so if you hear a bang once a month from the gym, you're not going to complain. But if you hear it,
hopefully you don't have a neighbor who does kettlebells all day every day.
Yeah, exactly.
Right?
If you hear it at 6 o'clock in the morning repeatedly because you have no gym floor in, then of course you're going to get, complaints about that. So from that perspective, it's less about, a black and white number criteria. And it's more about, as you said, risk mitigation and risk management and protecting the developer and the owner of the building from future complaints and from future, legal defenses and trying to address it all in design.
Right. And you obviously don't want to overdo it, like you mentioned at the beginning, because there's always the cost associated with this. We could potentially eliminate way more of the sound and if the noise, but it does come at a price. And at the end of the day, the consumers are going to have to pay a good chunk of that price, right? So being efficient and being within reason, I guess. Whereas within reason, is that's a key point, right?
And that's the truth. Sometimes, we work on gyms where you have a gym on slab on grade. And when your gym is slab on grade, then, instead of putting in an amazing gym floor, it's a lot easier to just cut the slab. And so you just run a this is not a joke. I mean, this is a real thing.
That's very true. That's very true.
That we see in gyms. And so, developers will say to us, wow, that's brilliant. Like, I'm so glad we didn't spend all this money on this fancy gym floor. Instead, we just cut the slab and, fire stop it, and then you're good to go. And then you don't have to worry about, then you can put in your, 10 mil gym floor or whatever you want to put in.
And have a kettlebell class every single morning.
And there you go. There's your dead ball slams. Have a nice day. So it's, sometimes it is about, the right type of design exercise and guiding the developer to not overspend where it doesn't make sense to.
Right. People say, I'm a new developer. I'm someone who wants to come into this mix. Or maybe I've done a few projects and I want to take my game to the next level. What are the top, let's say, 1, 2, 3 decisions that I need to make when it comes to the area of acoustics? Or maybe I could also reframe it and say, what are the top 3 questions I should ask my acoustic engineer if I want to make sure that my end product is within reason?
So I think that, an important thing is sort of in the question itself is to work with an acoustical engineer. Like I said, architects do learn a little bit about acoustics during their training. Some of them have gone over and above. A lot of them, most that I've spoken to, certainly have a pretty decent understanding of things like STC and IIC, but really it is limited, and it's not their fault. It's not what they specialize in. Right off the bat, even just getting an acoustical engineer involved is right away going to provide that level of guidance. And then the other thing is, really properly defining the target market. Is it a luxury market? Is it a condo? Is it a rental, but a luxury rental or a not luxury rental? Are you going to be involved for 20 years, or are you walking away after 5 years or 1 year? And so, kind of well defining that helps, the engineer understand what the target end goal is. Then in terms of conversations with the engineer, the type of acoustical engineer or consultant, I suppose, not all engineers, but the acoustical expertise that you would want on these jobs is somebody who is not only looking at STC and IIC. I mean, that's just like that's kind of where you start. That's day one. And then the rest of it is getting into the flanking. And some of these ways to address flanking are not expensive. This is something like in making sure that your suite demising wall interrupts the corridor wall and interrupts the exterior wall piece of drywall. Like, make sure that drywall is not continuous on the corridor, like past the suites. That is not an expensive thing to do. All you do is you just interrupt the drywall.
Just cut it.
So
yeah,
you just cut it. So it's not like all of these things are money to make your building better acoustically. It's just about having somebody who has the ability to look at these things from the framework of not only direct but indirect sound transmission as well. And so somebody who can really wrap their head around that. Also, it's not only architectural. You certainly want an acoustical engineer who can take a look at M&E equipment, sound data for some of the big equipment, make sure that they're addressing not only isolation of the equipment, but also things like piping, conduits, ductwork. I mean, these are like major things that are connected to the equipment that also can transmit vibration into the structure. So that's another thing where you really want an acoustical engineer to bring that, knowledge to the project, to the benefit of the project. And then probably the third thing comes into, that other territory of elevators and garbage chutes and compactors, and somebody who's, cool isolation is another one. I mean, somebody who's going to think of the things that you don't see on all of the architectural, mechanical, electrical drawings.
right.
Because
But they have an impact on the building.
But they have a big impact on the building. Absolutely. Car stackers, like, I've
huge.
seen, so somebody who's going to look at things that aren't as obvious on the drawings. Overhead doors is another great example, but still a very common source of complaints, a significant acoustical, source of vibration. So something, sound and vibration. So those are all things that, I would definitely be talking to an acoustical engineer about when you bring them in early.
If I want to educate myself on the topic of acoustics, not to become an acoustic engineer per se, but just to learn more, dig more, and keep ourselves up to date, are there any websites, resources, books, articles that you would point people to?
Absolutely. I think that, a lot of acoustical engineers have blogs. I mean, we have a blog. A lot of others, I'm sure, have blogs with really helpful articles as well. And so, making use of those resources. If you're in Canada, if you're not in Canada, this still applies. But the National Research Council, the NRC, has published, which is a government affiliated research lab, I will say, for those who are less familiar. NRC has published a bunch of really great guides with respect to acoustics. And so if you were to Google something like NRC publications, and then you look through those, that will take you to their website, and then searching for things like acoustics, that will really guide you through, acoustics in composite steel deck buildings and lightweight steel frame buildings and different, very specialized guides in there. For mass timber, a great resource, Woodworks has a guide, a list of acoustically tested assemblies. This is just for direct STC and IIC, but Like I said, that's where we start. So that's a great resource there of a bunch of test
Woodworks
data.
has a lot of material. Yeah, Woodworks both in Canada and America. Yeah,
that's right. So those compilations of test data from Woodworks is really valuable. If it's not mass timber, if you're looking at something like wood frame floor ceilings or steel stud assemblies, then on the National Building Code, the Ontario Building Code in Canada, those all have some great tested assemblies as well in the SB3 table at the back. So there's 50 pages of tested assemblies, a lot of which have fire ratings as well. And so coming up with just some simple STC and IC ratings, those are some great resources. And then, a lot of those blogs, that's where you can get into more information about mass timber acoustics or fitness, noise, and vibration, sound transmission between suites, addressing property manager complaints, all of these different, you can find in different blogs.
Where can people find you if you want to share some information?
People can find me. So I work with HGC Engineering, and that's where you can find, our blog and a bunch of that info. And if you want to reach out to me, my email address is S for Simon Edwards, SEDWARDS @hgcengineering.com. And if anybody has any questions for me, then just send me an email.
Thank you very much, Simon. It was a fun episode. I learned a lot. Any follow-up questions, anyone listening, please feel free to reach out and ask the questions. And thank you again, Simon. Hopefully we will do a round 2 in the near future.
Sounds good. Thanks for having me, Pym. I appreciate it.
Thank you. Just one last thing before you leave. We have developed a comprehensive guide of resources that people in the industry are using to make better decisions or keep themselves on top of the trends, learn about new products, technologies. These include books, websites, blog, podcasts, YouTube channels, apps, and softwares. And people are using them to make better design decisions, investment decisions, or engineering decisions. And I'm sure that you're going to find this very helpful, but hopefully it will save you dozens of hours when you need it, and who knows, maybe even more. This is a live document that we're going to keep updating every few months. Please go to our website, realestatedevelopmentinsights.com, and you can get a free copy of this document for yourself, realestatedevelopmentinsights.com, to get the free PDF resource. Thank you very much.